So, till now we have discussed the subtopics like force, forces due to an interaction, and exploring forces. Now, let us discuss activity 7.5. Before we start, let me remind you one thing, that force can change the state of motion and force can change the shape of an object. See, by applying the force on any object, what will happen with the object? The state of motion may get changed, or else the shape of object will get changed. Okay, so this is only the thing we are going to discuss in this activity. So by keeping these things in mind, let us see activity 7.5. If you see the activity 7.5, they have given certain examples in the first column, and in the next column how to apply force. It means how we are applying the force on the object. Okay, and the next column is for diagram, and the last column is for action of force. In the action of force, they have given next two columns. Okay, two more columns they have given, and in that they have given change in state of motion and change in shape. Okay, by applying the force on the object, we have to tell whether there is a change in the state of motion of the object, or else there is a change in the shape of the object. Okay, so by taking one examples, we have to tell by applying force on the object whether there is a change in state of motion or change in shape. Okay, so the first example is a lump of dough on a plate. Okay, so if you observe here, on the lump of dough we are pressing it. Okay, how we are applying the force on the dough? By pressing it. So by pressing it, what is happening with the dough? The shape of the dough is getting changed, right? Its motion is not getting changed. Okay, it is not moving from one place to the another place, right? Its shape is getting changed. So I have written yes in the column change in shape. Okay, no in the column change in state of motion. Now see the second example. Spring fixed to the seat of a bicycle. So how we are applying the force on it? By sitting on the seat. Okay, by sitting on the seat, what is happening? The shape of the spring is getting changed. Okay, it is not moving from one place to the another place. See, you can observe here, the bicycle is moving from one place to the another place, not the spring. Okay, spring is at one place only, but its shape is getting changed because of the force applied by the person by sitting on the seat. Okay, so only I have written yes in the column change in shape and no for change in state of motion. Then next one is a rubber band suspended from a hook or nail fixed on a wall. Okay, how we are applying the force on this? By applying the force on the free side of the rubber band. Okay, here the person is applying force from the free side. Okay, by applying the force, what is happening here? There is a change in the state of motion. Okay, the rubber band is getting changed. The shape is also getting changed, and even the state of motion is also getting changed. So at both the side we have to write yes. Yes for change in state of motion and yes for change in shape. Then the next one is, the last one, it is a plastic or metal scale placed between two bricks. Okay, so how we are applying the force on this? By putting a weight at the center of the scale. So by putting the weight at the center of the scale, what will happen? The shape of the scale will get changed. Okay, it will bend from the center itself. So I have written yes in the change in shape column, no for the change in state of motion. Now conclusion from the activity 7.5. So what we are having the conclusions after solving the activity 7.5. So the first conclusion is may make an object move from rest. Okay, so after applying the force on the object, what will happen with the object? May it will move from rest. Then the next one is may change the speed of an object if it is moving. See here in the example, the car is moving already. Okay, if you apply more force on the car, what will happen? The speed of the car will increase, right? So that is only the second conclusion. May change the speed of an object if it is moving. Then the third one is may change the direction of motion of an object. Okay, while moving only, what will happen with the object? The object may change its direction. Okay, then may bring about a change in the shape of an object. Okay, by applying the force on the object, what will happen? The shape of the object may get changed. And the last one is may cause some or all of these effects. The important point is here is nothing but none of these actions takes place without the action of force. Okay, so without applying the force, the objects cannot move by itself. Okay, so thus an object cannot move by itself. It cannot change the speed by itself. It cannot change direction by itself. Its shape cannot change by itself. So the next thing is contact forces. See, till now we are having idea that the force can be produced if there is a contact between the two objects, right? So that is only the next bit ours, that contact forces. In the contact forces, see, can you push or lift a book lying on a table without touching it? Is it possible? Can you lift a bucket of water without holding it? Right? Is it possible to lift or push a book which is lying on the table to move it? Or we can lift a bucket without touching it. Is it possible? No, it is not at all possible, right? It can be possible with the help of muscular force. So how we can define the muscular force? The force resulting due to the action of muscles is known as muscular force. So you can observe here the man is rowing the boat, right, with the help of. Then one more example, a person is pulling trolley, right? Here the person is pulling trolley with the help of muscles itself. Okay. And the next thing is friction. So how we can define the friction? The force responsible for changing the state of motion of objects is the force of friction. Okay, the examples for this: a ball rolling along the ground gradually slows down and finally comes to a rest. Okay, so see, if any ball which is rolling on the ground, okay, after traveling a certain distance, what will happen? The speed of the ball slows down, right? And finally it will come to a rest. Okay, so while moving, at that time only the force of friction will produce. Okay, when it will come to a rest, So what will happen? There will be no motion, there will be no force, and there will be no force of friction as well. Okay, and like that only, if you observe the next example, that is when we stop idling a bicycle, it gradually slows down and finally comes to a rest. Okay, if you pedal the bicycle, at that time the bicycle will move. If you once stop pedaling the bicycle, what will happen? It will slows down. Okay, the speed of bicycle will slow down and finally it will come to rest. And here also, while moving only, it will produce the force of friction. Okay, and force of friction will always. So this is about the force of friction. Okay, so the force of friction always acts on all the moving objects and its direction is always opposite to the direction of motion. If you observe in all these examples, okay, you can easily tell that the force of friction always acts on all the moving objects and its direction is always opposite to the direction of motion. Since the force of friction arises due to the contact between forces. Then we'll move towards the next thing, that is non-contact forces. In non-contact forces, the first thing we are having, that is magnetic force. So see here, the force exerted by a magnet is an example of a non-contact force. Okay, the force which is exerted by the magnet. As we know that the like charges, okay, repels each other and unlike charges attracts each other, right? If you take the example of magnet, what we will tell? Like poles repels and unlike poles attracts, right? So that is only the magnetic force. The force exerted by a magnet on a piece of iron is also a Then the next bit is electrostatic force. The force exerted by a charged body or another charged body or uncharged body is known as electrostatic force. Okay, so how we can define the electrostatic force? The force exerted by a charged body on another charged body or uncharged body is known as electrostatic force. Okay, if you observe here in the examples, the tap water is getting attracted towards the balloon, right? Without touching it, right? The tap water is moving towards the balloon. And likewise only, if you observe the next example, here the hairs are getting attracted towards the straw. Okay, it's a straw. The girl is holding the straw. So just by holding the straw just near to the hairs, what is happening? The hairs are getting attracted towards the straw. So this force comes into play even when the bodies are not in contact. So this is about the electrostatic force. The next thing is gravitational force. See, gravitational force. Without being aware, we all are under gravitational force, right? So objects or things fall towards the earth because it pulls them. This force is called force of gravity. The gravitational force is invented by the great scientist, that is Sir Isaac Newton. Okay, so in the 8th standard, you peoples are having only the definition and some basic information about the gravitational force. But when you move towards the 9th standard, there we are having the deep study about the gravitational force. Okay, so how we can define the gravitational force? Objects or things fall towards the earth because it pulls them. This force is called the force of gravity. This is an attractive force. Okay, the force of gravity acts on all objects. Okay, whether it is living objects, whether it is non-living objects, whatever the types of objects will be there, on all the types of objects the force of gravity will act. Okay, and because of this gravitational force, we peoples are able to walk, and we peoples are able to ride our vehicles, right? If this gravitational force will be not there, what will happen with us? We used to fly, right? How the peoples used to fly in the space? Maybe you have observed, maybe you have saw some that the National Geography channel and all. In that they used to show some videos where the peoples went in the space. Okay, in the space gravitational force will be not there, right? So how the peoples will be? The peoples used to fly, right? Why it is so? Because gravitational force is not there. Okay, but here we are having the gravity. Okay, so because of that we all are getting attracted towards the earth. The force of gravity acts on all of us all the time without our being aware of it. Okay, and this idea of gravitational force has been given by Sir Isaac Newton. Okay, and about this gravitational force we will study in the 9th standard. And one more thing, let me tell you people that activity 7.